Hi, this video we're going to look at another example of finding the resultant force in two dimensions. In the previous video clip, you have learned how to use a triangular rule to find the resultant force, both the magnitude and the direction. The way we did it is we use a lot of trigonometry. So it's law of cosine, law of sine, and some geometry of parallelogram. So altogether, you can solve this. So now we are going to use the same principle and solve another problem, just trying to reinforce the concept. So here they give us two forces, P and Q, and giving us the angle between them as 25 degrees, and also P is 20 degrees counterclockwise from x-axis. And our goal is to finding the resultant, basically summation of those two forces, or people use R also, either one. And how do we do so? We are going to create a triangle in order to use the triangular rule. To do that, we're going to use the head-tail connection. So what we could do is, if I were just go ahead using this graph here from the head, I'm going to draw a parallel line to this force P, right? So it's going to be parallel. That's going to be the same length from here to here. It's going to be same length from here to here. And that's going to be our force P here equal to 40 Newton. So we move the P up there, and we know resultant is going to be, when we construct a triangle, it's going to from A to that. So the green line is going to be our resultant. So simply we draw the resultant, and we just need to solve them now. Now let's look at this triangle right here. So this force here is 60 Newton because that's your Q. And this side is going to be your P, 40 Newton. And do we know the angle between them? Can we find out the angle between them? Yep, similar to the last problem we did, right? Because using the parallelogram concept, so if you know this angle, then you will know this angle, because if this is theta, this will be 180 minus theta. For this angle, we already know that's 25 degrees. And so this angle will be 180 minus 25. That gives us 155 degrees. Right? So knowing that, we can find R. If I were trying to extract that top triangle out to make it easier to look at it. So this is 60 Newton, and this one is 40. And the angle between them is 155 degrees, and we can quickly solve this R, can't we? All right, law of cosine, we're rolling. So R is going to be equal to, I'm direct to go to the square root now. It's going to be 60 squared plus 40 squared minus 2 times 60 times 40, and then times the angle between them, cosine 155 degrees. All right, so trying to solve this along with me while you are going through this video. So I'm putting my calculator, 60 squared plus 40 squared, and then minus 2 times 60 times 40. Oops, I got something wrong in my calculator. Okay. Minus 2 times 60 times 40, then times cosine 155 degrees. Then we have to take a square root. Then I have an answer of 97.73 rounding in Newton. All right. So I think this number is reasonable. Why? Because this is 60 Newton, this is 40 Newton. This resultant is going to be less than those two add together, and it will be longer than both than each one of them. So I think that number is at the ballpark. So we figure out the magnitude of this resultant. R is taken care. Now we just need to know the direction. Again, the direction in statics is defined from x-axis. This is our x-axis, horizontal line, counterclockwise to this force. So if I were to draw this using the blue here, so x-axis counterclockwise to this force. This force is this green line, which is resultant. That's going to be the theta we are solving. And now let's take a look at, remember this angle is pre-given already, it's 20 degrees. And so in order to do that, we just needed to solve this angle, right? In order to solve that angle, again, using the parallelogram characteristic, this angle will be the same as that angle. So basically, this angle you're solving is going to be the same angle as that. Again, we're going to use alpha. So, okay, what is going to be the alpha? How do we solve alpha? Alpha translated in this triangle will be right here. That's our alpha. So you start to see it's basically the same concept you did in the last video. And we're going to use sine law now. So 60 degrees over sine alpha is going to be equal to, and now we already calculated the R. R is our 97.73 over sine the angle that's opposite to R, which is 155 degrees. So knowing that, we can find our sine alpha, cross multiply. Let's try to use our calculator. 60 times sine 155, then we'll divide it by 97.73, and my sine alpha is 0.26, rounding up. And if then we do inverse sine, then the angle I calculated is 15 degree 0.4 degree. So knowing alpha now, this is basically our alpha. Then we can find the theta. Theta will be just equal to alpha plus 20 degree, which is given. And then the answer will be 35.04 degree. That gives us the direction. And this gives us the magnitude. All right. So this is just a quick example using the triangular rule to finding the resultant force. And one last thing, very quick question. Is this a nut A here, the bolt right here? Is this at equilibrium? Yes, the answer is no. It's not at equilibrium. Why? Because the summation of the force here, resultant, which is sigma F, is not equal to 0. When it's not equal to 0, which means what? Not static. Right? Only when force is at equal to 0, then we know this is static. It's not moving. All right, that's for this problem. I'll see you next time. Bye.